Here's some things that really work. We have the pre-run spray valve. We've talked about that some. You cut out hot water use. You cut out, which cuts out energy, and you also cut out water use. It's a win-win situation. Just showing you how many gallons and how much gas savings you can therms that you do it in here per day out here. It's quite impressive. I'll let you read that yourself. You go to the next one. Let's just take a look at some other things. How about we talked about garbage disposers here, and there are plenty of good reasons for using garbage disposers. I'm using this as an example. Here's another case where a grinder uses, in a commercial setting I'm looking at, the ones in the houses are half horsepower or less, but can use anywhere from 2 to 12 gallons a minute and uses a lot of water. There are a lot of other things that are available out there, everything from scrap baskets to pulpers, and with that you get a lot of other good things going. Bottom line is that within our whole setting out here, we have a lot of different things to look at. Garbage disposers, dishwashers, boilerless steamers, this is just on the commercial side, x-ray film developers, vacuum pumps. If you go into a hospital, and I audit hospitals all the time, you'll find in a large hospital, if you have the old liquid ring vacuum pumps that are water cooled, each one of them will be using 5 to 10 gallons a minute going straight down the drain, and there'll be 2 or 3 of those running 24/7. That is like 30,000 gallons of water a day down the drain. You can replace that with a dry vacuum system that uses 30% electricity and 0 water. There are a lot of things we need to be looking at, and a lot of interesting things we get when we start looking at this. For instance, if you're doing toilet or restroom retrofits, and that's what I say with the toilet rebate program here. This is taken to the city of Austin, where we actually figured it out for that city. If you go in and you put in the shower heads, the faucet aerators, and a high efficiency toilet, you save about 25 gallons of water a day. That's 9,000 gallons of water a year. It works out to be about 25 kilowatt hours per year. If you go down and you do a dental vacuum pump, you're saving 250,000 gallons of water and 2.5 megawatt hours of electricity. You can read the chart. The bottom line is that a lot of times when you save water, you save energy, and when you save energy, you save water. And then we have the conflicts. These are just some of the boiler to steamers. How many of you have worked in a restaurant and know what a steamer is? Or know what a steamer is? And, just a whole bunch of people. Okay. Dental vacuum pumps. But I come to one of my favorite topics, and I'll just spend a couple of seconds on here, and this is cooling towers. Cooling towers are a very necessary part of our society, and they're going to be here for a long time to come and have a vital use in both the industrial and in air conditioning type practices. But be aware of how much water they use. Here is a large hospital in Florida, hot and humid. 43% of all the water in that hospital was used for the cooling towers. Now, granted, they could maybe be a little more efficient, but that was that. This is a 10-story office building. We're moving west. This is about the middle of the United States in the south. And here, this is a very efficient building. They have their kilowatt hours per ton hour on their HVAC system is running. The whole system is running at about 0.6. For you that understand this, that's fine. It means it's very efficient. They had the modern, up-to-date code toilets and everything, and the high-efficiency irrigation system. 47% of their water use was for the cooling towers. Huge use. Here's a study that was done in 2000 in grocery stores in California. And in this study, done by the American Water Works Association, AWARF, which is now no longer directly with AWWA, but 62% of the water use was for cooling towers. You can see where I'm going on all this. We can just keep going through here. But let's take a 750-ton cooling tower example running 24 hours a day, 75% efficiency, and 2.25 gallons per ton hour of makeup. If you go through and the cooling towers, no, that's pretty typical operational type characteristic. Well, by golly, that thing is going to use almost 25,000 gallons of water a day, 3.7 million gallons a year, and the capital cost of the water to provide the peak, the capital cost for the new treatment capacity at the water at a very cheap rate is around $50,000. Well, that's comes out to be pretty much what you purchase a cooling tower for. Purchase capacity is around $75 a ton. Installed capacity may be $100 a ton. And that just keeps on going. I won't make you read this one. It's too small. But this gets back to, well, what is the breakdown? Let's use those old air exchange systems then. The old direct expansion systems, like your home air conditioner does. It has that unit outside that blows hot air out. That was the heat inside your building, et cetera, like that. What is your difference? The difference is equal to about 0.3 kilowatt hours per ton hour, or maybe 0.35, somewhere like that. Just remember, it's worth somewhere between 3.5 cents per ton hour that you save on electricity. That's why you use a cooling tower. It is more thermodynamically efficient. But you're using 2.25 gallons of water. What does that cost you? It depends on where you are. Here's cost all over the United States. You can see if you're in Seattle, you're paying $17 a 1,000 gallons. That's 1.8 cents a gallon, by the way. That's a pretty expensive water for water and sewer. And this is what it works out to be. That's 4 cents a kilowatt hour there. Per ton hour there, just for the water supply. You get down to Pittsburgh, which has pretty cheap water, and that's 1.62 cents. Well, out of that 3 cents, you've used up half of it in Pittsburgh, and you've actually gone over it in Seattle if you're not getting any kind of wastewater credit. If you look at just the water supply and stuff, that can be different there. There's a lot of stuff coming down where we're going to have these interesting conflicts that are going to be worked out. I do not want things to happen like I was at this water footprint conference. A major international manufacturer got up and said, because we've had problems with water supplies, we're going to outlaw cooling towers at all new facilities. That was not a wise decision. I've also seen backwards where people are saying because cooling tower systems are more energy efficient, we want to have every home have a cooling tower. Can you imagine a homeowner trying to operate a cooling tower? They can't even operate their swimming pools. And it'd be a horrible waste of water and would be stupid. Now, we have to start thinking, as a profession out here, and you're the professions that are going to be doing this, how do we come at an equitable balance with this type of situation? I don't have the answer, but I want to leave it up to you. And remember, if you're building a new water treatment plant, where you're getting your water from a lake, and you're building a brand new plant, for every gallon day of capacity, it's going to cost you probably $2 to $4 per gallon day of capacity. If you build a 100 million gallon a day plant, it's going to cost you $200 to $400 million to build that plant. That's a lot of water. A lot of money for that water. If you're doing an existing addition to a plant, it's somewhere between, say around $1 per gallon day of capacity. Now, that's not dollar per gallon, it's per gallon day of capacity. This is like in tons, not ton hours. That's a lot of money. Desal is $5 to $8 per gallon day of capacity. If you build a 100 million gallon a day desalinization plant, it's going to cost you $500 to $800 million. That's a lot of money. What do you design for? Look at the wastewater, anywhere from $1 to $5 depending on their wastewater discharge permits. Most 2020 permits, you can still build them for $1. There are very few of those, and if you're any kind of large city, you're going to have a much more stringent water and wastewater permit. It's going to cost you a lot more. So if you're putting in that 750-ton tower, and on a peak day in the summer, when you're having a peak day on water use also, because everybody's irrigating then too, you use that 25,000 gallons of water, you can easily be costing yourself $100,000 in new additional capacity for the water and wastewater system. That's not ever talked about. It's not part of the calculation on there, but it is a cost that is borne by society.